What is an E field? An E field is an area where a charged particle would experience a force if placed there. Much like a gravitational field from a planet, it's an area where if a body enters that gravitational field, it would experience an attractive force due to gravity. So E fields are going to connect to Coulomb's law and connect to the forces here. But first we need to deal with some of the sign conventions for an E field, or the direction of an E field. One of the ways that we define the direction of an E field is away from positive. So if I have a positive 1 microcoulomb charge here, I would define the E field as away from it in all directions. If I had a negative charge, we could also define it as toward negative. If this charge is bigger in magnitude than that one, and so when I draw the field lines, I should represent more lines to indicate a stronger charge. A third way that we define the direction of an E field is as the direction a positive charge would move. You'll see that this definition is consistent with the two above it. If I place a positive charge here, it'll move that way. If I place it here, it'll move that way. If I place it here, it'll be attracted in and will move that way. A third way we sometimes see field lines is in what we call a parallel plate capacitor, which gives rise to a uniform field. In these, we have it connected to an electrical circuit, and electrons are brought in and they build up on one side. The other side, relatively speaking, is positive. The way I would draw the E field here is away from positive toward negative. In this problem, the E field is directed upward. If I place a positive charge here, it will indeed be repelled from positive and move toward negative. We will use these sign conventions in the direction of the E field to determine the direction of forces acting on charged particles.